get a reductive handle on some of what the artist is better capable of getting a handle on, but without reductive language. This is reductive language. So we're still in an exquisitely reductive domain, but it's different than this one. And so I'm going to assert that these are the numbers that nature is expressed in. Whereas we call this series of numbers, we mathematicians call that the natural numbers. I think that's an unfortunate expression of our over-enthusiasm as the sorcerer's apprentice. You know. And we've done this. I think we in astrophysics are doing this. And there's nobody to stop us but the sorcerer. So now I want to draw just a few more circles so that we can have a visual way of distinguishing, recognizing the pattern of circles centered around A and the pattern of circles centered around B. So what I'll do, I've never done this before, but with the advantage of the video, I would like to draw one of the circles centered at A in black and the circle centered at B in red. I think. So, good place what?
This is a good house.
Okay. Probably. Oops. Wrong thinking. Oh. Okay. There's a good black in there, so I don't need that. Take that up before the close up. All right. So I want to draw. Now, there is a kind of dance, the kind of rhythm that a little girl learns at 8 or 9 in jumping rope or in jacks. Guys learn it. I learned it in jumping ropes, in jacks. But there are some other places that guys learn too, about the interplay between what goes on creating the family of circles centered here and the family of circles centered here. Now I'm going to draw the next circle centered at A goes from the largest circle at B on the green line. Now I'm going to draw that and then indicate a way of saying that a little simpler, and not so. Okay. Well, takes a little time, patience. See if you can make that change. Now, okay, so we've got a family of 3 circles centered at A and a family of 3 circles centered at B. Now, my 4th circle centered at A is going to have a center here, and its radius is such that it passes through that point there, which is the top point on the green circle centered at B. Now, and I'm going to put all these in black. All the circles centered at A, I'm going to put in black. And all the circles from now on centered at B, I'm going to put in red so that we can see 2 families.
Here we go. Excellent.
Right. And now I want to draw a partner to that one in red. Centered at B. And there's centered at B, and the radius is such that it passes through the topmost curve. Yeah. I need a more robust spread. You had one. now I want to draw one more, a red circle centered here, whose radius is such that it passes through there. And I want to draw a black circle centered at A, whose radius is determined by the biggest red circle. Now, I don't know how to say that, and see that the relationship between the interarticulated recipes for these developments is not linear. It's not something that you can say easily in a non-German sentence. And that means there is relationship here that is a great deal more complex than the relationship that gave us these. But what I have done could be taught to a middle school kid without all this intellectual stuff that we are anticipating. Just do it, and we will find that the middle school kids enjoy what they're doing without all of the whatever you have to do about the mathematics or whatnot. We just use color properly and have them know the green lines, the green circles, the black lines, and so on, and the blue circles. And so now I'm going to, what I wanted to point out before the thing gets any more complicated is one more piece of language. If we assume that the green lines are parallel and that they are perpendicular to the black line, then this is a right angle. And from here, AB is the side of a right triangle whose hypotenuse is the radius of the blue circle. So AB is the side of a right triangle whose hypotenuse is this square root of 2. What can we say about the green? See, the green circle has a radius here. This is the radius of the green circle centered at A. That radius is the hypotenuse of a right triangle, one whose size is 1, and the other side is what? This is the radius of the blue circle. That's root 2. And the root 3 is that hypotenuse. Root 3 is again the hypotenuse here of a circle whose radius is the blue circle. Now, what then is the hypotenuse here? This is the hypotenuse of a right triangle whose side is 1, and a red circle. The red circle, I'm asserting, is square root of 4. Now, I can make a little test on that, maybe to see whether we claim this to be the square root of 4, right? Well, let's see how that compares to the diameter of a circle. Diameter of the circle was our old friend 2. Well, our 2 we think of as the square root of 4. Well, I'm saying this is the square root of 4. This is not 2. What is 2? Well, you come back here to the definition of 2. This is a radius of the blue circle. And so 2, and this is square root of 2. And so square root of 2 times the square root of 2, there is a square whose sides are the square root of 2, and that is our 2. So what this designation does is a revolution. It kicks off the number line, these numbers, our old numbers that form the number line definition in conventional mathematics. These are kicked out. These are replacements on the number line. And And each one of these provides a square. The square root of 2 times the square root of 2 gives us an area that is 2. The square root of 1 times the square root of 1 gives us an area that is 1. Square root of 3 times the square root of 3 gives us an area that is 3. And we just have to relearn that language of arithmetic. And it's difficult for us, but it'll be less difficult in 10 years from now when both of these are taught in middle school and in grade school. The time has come for us to learn some new mathematics. The time has come for us to recognize that the mathematics that we're using is simply not adequate, and this is an expression of it. Now, that's what I was trying to refer to earlier in some conversations with my friends when I was reading from Descartes' Dream, The World According to Mathematics. A statement from Descartes' Dream. It says, mathematics is changing, and its role is changing. Those who entered the profession before the onslaught of digital computers are old enough to feel this change profoundly. The mission of this book, Descartes' Dream, is to point to the necessity, as that change occurs, of developing a heightened awareness of the relationship between humans and the mathematics they have created. And we must remember that this is our creation. And assigning this as one is our convention. And you guys don't know that, but I know. And I'm old enough to feel this change because I remember before the computer. There is hardly an area into which mathematics has not yet penetrated or might not penetrate. Just as all material objects, no matter where they are located, are subject to the law of gravity, so mathematics and its ability to deal with quantity and space, pattern, arrangement, structure, logical implication has become, as Descartes would have wanted, the unifying glue of a rationalized world. We have to generalize, we have to broaden the meaning of